Okay, what we're going to do is just go through the code for the application that sits on the Raspberry Pi. The code files are included in this post. If we just go through now some of the main ones just so I can explain a few things. Now, immediate disclaimer, this is been done so it's easier to understand. So there will be code reuse. Some things are done in a longer way than necessary, just because it makes it easier for people that are looking through the code files to be able to take the parts that they need to work on their own projects. Just copy this onto another machine so it's thrown out. So what we've got is our main page. So our main page is very simple. All it's going to do, it's got a title and then it has two text blocks. I've not done MVVM here because it's quite a small app, so there's no real need for anything like that. And then we've got an order, which will give us some status on the order, and then our chosen slot. The code behind for this, we have a few concepts at the top, which are the pin numbers. So that's the GPIO pins that are going to be used on the Raspberry Pi. And we also have a couple of statics for things that are going to be used only once, but we'll only one thread at a time, so we're just going to have that well organised, and that's so that we don't end up creating multiple orders. So when we in it, so my cat's just sat on the keyboard. So going through the main page and initialize, we're going to create our slot. So this would not normally be in the code file. It's just easy for you to understand from here. So what we've done is these are slot IDs that we get from the Amazon DRS web pages when we do our configuration. So I've just given a friendly name and then just add a number here. So that's slot 1, 2, 3 and 4, and that's the IDs. And this is just so that when we click for our selector button, it'll just tell us what version or what genre we've selected for our next order. As again, this is a development system, so I've just thrown an exception out if there is a problem here during initialization, just so we can immediately see, so we can work on that. Thankfully it's not been used so far. Under initialize, we're using the GPIO controller. So first of all we need to get that from the device. If I make a mistake and don't use that in the remote machine, it'll just give me a nice warning there. And then we have the pins. We have our button and our selector. So the button is what we're using for the book. I'll just set a few basic settings here about, so you can't just quickly press it a couple of times. Just standard things you would do on a button via the IoT stuff. And then when the values change, I've just set up an event handler, and I've done the same for the selector, and the selector is where we choose between our 4 different slots. Next thing, I'll come on to the events shortly, but next thing we'll do is just initialize our timers. So under the guidelines for DRS, they want a status update at least once a day. So I've just set one up for 12 hours. So while this is running, we'll just send a status update every 12 hours to say we're still there and everything's fine. So this is just a basic dispatch timer, and then it goes for send status. So these are our main logic files, which we'll come on to shortly. Similar code here for our initialize order timer. However, we don't actually start the timer in this case because we don't want that until the book has been lifted off the holder, and that way we get a 30-second lead. And so if you just pick up the book and think, what's on the back? Oh, don't want to make an order. Put it back down, and no order made. And that's why there's slightly more logic. Slightly more logic here, and just to make sure that we update the text accordingly so the user knows what's going on, and also we can make our order. So just coming down the file. So our events for when we press our button, so our selector and our button. The selector is just simply going to go through and iterate through the slots, and then based on the slot number give the name, and that's what it's going to do here. And then that's just going to come up, so it'll just say like selected slot is, and then if it was slot 1 it will come to us fuller, just so the user knows what it is they'll be ordering next, so they can make that selection quite easily. And on the button, it just gives a bit of data. The book's in the holder, this is more for while developing it so we can see exactly what's going on. Yeah, there's a book in the holder, order's about to be made, and then it launches a timer. And if you put the book back down, it just goes back to book in the holder, and we'll see that when we look at the actual device shortly. And make order and send status is just using our service actions. So we will go into this file. So service actions is the main logic that we're using. We have a state, which is just a helper class here, which allows us to store the authorization IDs, refresh IDs, and details such as that. I've just deserialized into a local here because I'm doing some testing. But then we just save these as it persists between sessions, so if the power cuts out, it's not a problem. We have authorize, which is only really used in the first case. It's only used by our management website, so we're not actually using it in this, but just so I'm going to share the code and so people can see what it is we've done and how to use it. And this is what gets our authorization code and refresh token, and that can only be run once, otherwise we'll just get a failure saying you've got an invalid code. Once this has been done, all your next actions will be to call a refresh token. So when we call this, let's get to the get refresh token. This is just going to the API address, and then I've just created another class called auth, which has all of the details we need. So it's refresh token, and I've just taken it from my state, which is the actual refresh token value, the client ID, and the client secret, and return URI, which is actually just localhost for our thing. And then I have a class here which just goes through and it formats the web request in the correct format for this type of call. So this one will be URL encoded. One of the things on DRS is that all of the calls appear to be quite different. So some of them require URL encoded in the body, some of them require JSON. So what I've done, just to make it easy for people reviewing via this page, I've done each one completely separately. So we've got that for refresh, and then we have another full file here, full method here covering everything for the replenishment, and all that does is takes the slot ID. So we go back to our main page CS. We just call replenish with the selected slot ID, and that all goes in the URI this time rather than anywhere in the body. You just have to have specific headers to allow this to happen, and in this case the authorization code goes in the header. Like I said, each one appears to be slightly different. I've got quite heavy exception handling, just because if you're trying to run through this, like simple mistakes like trying to use the authorization code and you actually set up twice will throw an exception, and I spent some time trying to figure out what those exceptions were. So for this demonstration purpose, I've actually left the extra handling in here just so that people who do have a problem can just go through and should be able to help them on their way from that. And then the final one will be the send status request. Again, slightly different. This one needs, in the JSON body, needs to have the time. So we just send it that. Okay, so that's our service actions. The only other files really to show are this. Our save state is actually That's more of our keys, so we don't really need to go through that. That's just where I'm storing all of the information. You'll see some horrible comments where I've just removed some of the sections that weren't working earlier, but that's just for me to use. It makes it easier for me holding the information. And we have our auth, so this is what we're using for the refresh token and also the access token. Each one requires a slightly different thing, but this is what goes in the body. So all I've done is create a class here that takes all of the values, allows you to change them as necessary, but then just has a get body request, and you call that, and it just returns what's needed for your service call. And we look through the code files, it should be fairly self-explanatory on what that one is doing. And that's really it. Obviously the only gotchas is on this one are the GPIO pins, which is why I've just set the constant, so I only use pins 5 and 4. But that's in the actual diagram for the hardware, so you'll be able to see those. But if you want to change the pins, use a different one. Say you are using an LCD display just with a single line on, and you need to use more pins because you've connected that up. You just need to make your changes here, otherwise it just won't pick the system up. And obviously in the service actions, ensuring you've got the right addresses through. But the main problem is going to be if you start sending the wrong access token or refresh token through, which is why I've left the extra handling so you can just see and be able to determine that yourselves. So that takes us through the code. Now, because I've got this on a Raspberry Pi using Windows 10 IoT, so I've now deployed this to the device. So what's next, we'll just look at the device itself and see this running.